in the technical examinations of stone sculptures to see if they are ancient or not, especially in places such as Egypt, in which there is a very dry climate, desert, sand. There are often in buried objects two processes that go hand in hand. One of them is a continuous deposition of material which give rise to what is called patina, and that is usually an accretion of either siliceous or metallic components that come by direct deposition of sand and its components, or metals or metallic salts dissolved in groundwater and carried onto the surface of the objects, where the water may evaporate and form what becomes later insoluble deposits. And there usually the manganese and iron salts predominate, and they form little accretions in addition to the glaze or patina that forms. They form accretions in form of dark or even almost black crystals or crystallite compounds. And these are insoluble manganese and iron compounds, and they are called dendrites because they look like little trees or tree-like compounds. And these dendrites are extraordinarily hard and insoluble and cling tenaciously to a stone surface. Now this is of interest because it has not been possible to imitate these kind of dendrites. You can make dendrites of all kinds, but they are never hard, insoluble, and adhesive to the stone. So dendrites do form a very interesting basis for judging antiquity. The patina that I mentioned before is a kind of a glazed surface that is transparent, or at least translucent, and is very thin but also extraordinarily tenacious. And you've probably seen or heard patina on other objects, on ivory, on copper, and so forth. And the name patina means different things on those other things. But on stone, especially the desert varnish, as this particular patina is called, is also indicative. And of course, you cannot really see it with the naked eye. It takes a microscope, or at least a good hand lens or so, to even become aware of it. But it does give you kind of a general impression, and the interesting thing is that it cannot be washed off. The Egyptians like to produce an artificial patina by burying objects that they want to fake, or that they have faked, and they want to make look as if they were antique. They bury them in the sand or in dung or whatever, and produce an artificial patina, but that washes off fairly readily. And really ancient objects, they are impermeable to such washing. So that's the process of deposition. At the same time, concomitant with this, there's a process of erosion, which comes about by if the object is buried in sand, by the rubbing of sand grains, slight shifts, or if it's outdoors and sand is blown over it by the wind, there is a kind of an erosion pattern. So this is kind of works against the formation of the patina, or at least it interferes with it, but you can see the distinct influences quite well in really ancient objects. And again, it is very difficult to produce this sandblasting action artificially. I say difficult. I don't know if it's even possible. Certainly, in the days that we are talking about, in the 20s, when the particular objects of interest were produced, there wasn't any such fine sandblasting technique. Just to tell you what I mean by this, as compared to modern abrasive processes, the limestone of which the sculptures of the Mansoor collection are made are a so-called nummulitic or foraminiferal limestone. That means that it is formed from sea deposits which contain a lot of very small shells or shell detritus, and they actually contain these minute shells that are as large as a millimeter but also very much smaller, so they can be seen only with a microscope, I mean, except for the very large ones. Now these are also a calcareous compound, a calcium carbonate largely, and their hardness differs only very little from the matrix in which they are deposited, also calcium carbonate. And then if the processes of the wind blowing or the fine rubbing of the sand goes on, it is the slightly softer calcium carbonate matrix that is abraded more than the little shells, and they stick out just a little bit above the matrix, quite generally speaking. Now, if you were to use a regular abrasive like emery paper, so even the finest garnet paper, so forth, it would flatten it out quite evenly, and it would not show this exaltation of the little shells. So this is a kind of an interesting thing that you can observe just almost with a hand lens, but certainly with a low-power microscope on many of the objects that we have been speaking about.
The Mansoor collection has objects like that.
Yeah, exactly, yes. You can see it almost everywhere. And every object that you look at, they will show this, this phenomenon. So then there is another process of the original artificial erosion, if you will, the polishing of the finished object, of the almost finished object. It was polished not as we do today with emery paper or whatever, but rather with rags or other holders of sand, of quartz sand, which is very hard, and which, when rubbed over the surface, will produce irregular grooves. I mean, nearly parallel, but not quite parallel grooves. And this is very typical of the polishing marks that you see there. Also, they used simple and single pointers rather than these other more general procedures. And you can see that also. So both the artificial and the natural erosion patterns are quite visible on there, and you can distinguish very nicely how the deposition processes and those of erosion have competed after a fashion.